Okay, this is a demonstration of the asynchronous web server running off the laptop there. It's a Python fast API server done through Zunicorn or some kind of asynchronous TCP interface. And so here it's got one GPIO, and we can control these over, and even though it's connected to the serial, it's over the Wi-Fi. I can turn this on or off. I can also turn all of them on, or just two of them. And interestingly, when I lose power, there's a timeout, and then it shows disconnected, and it flashes red. When I reestablish the connection, unfortunately I lose the memory of the pins, but there you go. So the most interesting thing is this is a completely asynchronous website, and so you can go and do it, and then it broadcasts changes to all of the clients connected. So any change, those two, is on them. In fact, it works on in pretty much an indefinite. There's probably a built-in limit, but let's try it here on my iPad Pro, because I am a professional that Tim Cook wants to be professional. And I was shopping for eyeglasses, and so let's close those tabs and let's open up a new tab. Okay, so we're going to connect to, we can't connect to local host like we do here, but we can connect if I know the IP address. I can go let's see, and it's on port 8000, not 888 like it used to be. Oh, I have to type in the address correctly. It's not 125, it's 1200. There you go. And so now, and it has the same state. Now I can have a touch. So basically I have a little web app instead of having to build a full-blown application. This is probably the easiest way to make a GUI interface for a user, is just serving over HTML. Of course, if you had a proper web app, you would have some kind of credentialing service or login service, and there would be all kinds of like node packages and all that kind of stuff, but and frameworks. But Angular, React, oh my gosh. So yeah, but and the cool thing, let's see what happens when I disconnect. If I go to I can see these are all the messages flying back and forth, and it's all happening asynchronously, so nothing's blocking each other. It just happens in live time, and there's rules for, like, if this is true at this point, it follows this kind of flow path, and you have to define that, and you can get kind of spaghetti codey. And that message is the heartbeat from this. It'll time out after 10 seconds or 6 seconds, but every 5 seconds it sends a heartbeat of what the pins are so that everybody is up to date. And you can see the host, the WebSocket is the identity of the person doing it. So yeah, let's see, what did I want to show? I want to disconnect. So if I close this, connection closed, you see that? So that's from the server sending that message. And then we shouldn't get any failed messages like that when I do that. So it removes the client. When the client disconnects, it removes it from the people it's trying to broadcast out, so you don't get any failed messages. So the server is as efficient as possible, getting blocked as little as possible, wasting as few processor cycles as is humanly possible. Although on a multi-core M1 processor, at least for this laptop, it's not a big deal, but you could have this kind of logic running on an ESP32. You could have this as the web server. It doesn't really matter too much, but Python's implementation is very, very robust. It makes programming an absolute joy. Well, gentlemen, I hope you enjoyed this demonstration. Again, download the code using the right code thing, and I would ideally try to install everything through the to make everything work. open the VS Code, this file right here in the main directory. It'll be kind of confusing because it'll look like this. You'll have lab 1, which has client and server in it as well, so you get 2 instances of that. But if you open up the server instance, it tries to run a script. It might not run it that well, but anyway, it has to be like this in order for Platform IO not to freak out. It has to have the build file right. It has to have its build projects right here in the main directory. You can have multiple projects, they just have to be right here in the main directory. Just a heads up if you're using VS Code. And then what else? Oh, the main way to run the server is, and then we can kill the server, we can Control C, just CD into the directory that it's located. This is mine. I just kind of refactored everything to be in this projects folder. This is now its own parent repo, so there's 2 repos in here. This is one of the 2 child repos called a submodule. And that's the way to properly do this in Git, and I did that for the build system. And this is the build system. You go into here, you click run, and then it runs this pip-env, and it does all this kind of stuff to make sure that it has all the dependencies for you. You don't have to go and manually add all the system, all the Python dependencies to your system through pip. It'll do that for you in a local folder, and it won't affect all of your Python goodness outside of there. And it'll make sure you've got the right Python version as well. So we're all on the same page. Hope you guys like that. Oh, there's also, if you want to look at the output messages, all 3 of them have them. So you've got them on the terminal. I can connect to the terminal here. You get nonsense for the first little while, and then it figures out what the messages are up to a certain point. It can determine them. And then this is just kind of, yeah, so get sent GPIO pins. This is the server log. All of them have logs that are going back and forth. Even this, if you look at the JavaScript, here it is. I'm gonna have to upload, this is 7 minutes long. I'm gonna have to upload this to YouTube, but yeah, we'll go from there. I hope you guys like this.